Yeah, I'll be talking about ordinals and what's been going on Bitcoin lately. It's kind of this new thing, kind of a renaissance, rejuvenation of on-chain activity. Um, yeah, so let's start. I'm not the best at making slides, so bear with me here. Ordinals basically is two systems. The first part is ordinals or ordinal numbers, and on top of that, you have a thing called inscriptions. And what this basically enables is this fun little protocol where you can put like cryptotic bucks and like pictures on the blockchain. It's basically an NFT protocol for Bitcoin. So how does ordinals work? So the basics of ordinals is to assign every satoshi. A satoshi is the smallest unit of a Bitcoin. So one Bitcoin is made up of 100 million satoshis, and assigning every satoshi a number. The way we do this is when Bitcoin is mined, when new Bitcoin is created, you can see exactly, you assign it a number, and then you just track it across transactions. And the way this works in Bitcoin is that in Bitcoin is very different than Ethereum. It doesn't have an account model. It has a UTXO model where you have inputs and outputs, and then you just track the satoshis like first in, first out. And that's kind of how you then can have these stable identifiers on Bitcoin that kind of persist across transactions. In Ethereum, you have an account, so you have kind of this persistent kind of identity. In Bitcoin, you don't have that. So every transaction kind of breaks up this UTXO and creates new ones. And tracking satoshis enables one to have the stable identifier, and then you can do a lot of stuff with it. The next kind of thing I kind of want to define is a digital artifact. So we don't like using the word NFT because it's kind of a complicated acronym. People don't really understand what it means. But there is actually a very elegant word that's kind of very clear. It's like a digital artifact. And just to quickly define it, it's basically a thing that has a clear owner, and it's like your thing that you own. It's like holding a piece of like art or piece of jewelry in your hand. It's complete in itself and can only be changed by you. So if you own it, you can do whatever you want with it. You can destroy it, you can paint on it, it's yours. And of course, it can only be disposed of you. So you're the complete owner of it, and you can trade it on your own. And inscriptions are a manifestation of these kind of principles. Just, to kind of compress that all, Bitcoin, inscriptions are immutable, on-chain, Bitcoin native digital artifacts. So I'm going to go a little bit into the technicalities, and then later I have some nicer pictures. So how does this work on a technical level? So so the nice thing about like ordinals and inscriptions. So the first part was the ordinals, which are the actual satoshis, and then on top of that are the inscriptions. And the inscription is the actual data that you inscribe. And the way this works is that you inscribe this data onto a satoshi, and then you can track the satoshi, and that's how you kind of have this artifact that you own. And the nice thing about like ordinals is that they fit seamlessly into Bitcoin. Like there didn't have to be a soft fork or a hard fork. It works now. Like Bitcoin development is very contentious. It's very, very difficult to make changes, but we kind of found a way to kind of make this work in a kind of very seamless way. The nice thing about like inscriptions is that also all the data is stored on chain. You might say, this is kind of stupid, like you put all the data on chain, but if you look at like collectors and people that collect NFTs, they actually value having one place where all the data is stored. So you don't have, and also from a development perspective, it makes it easier because you don't have any dependence on IPFS or Airweave or some other kind of, or Filecoin or something else. You have everything on chain on Bitcoin. And the way we did this is that we put the data into a Bitcoin script. And if you see, alt false, alt if, this is kind of like, that's kind of stupid. This is what we call an unexecuted conditional. So it's just something that will never execute. It's just a way to push like binary data into the witness of a transaction. And we call this kind of structure an envelope. And this is where we kind of put all the data. And this is kind of a very basic inscription. The first part, the ord, is the protocol identifier. So it just defines what protocol you're using. And then we have kind of fields. And fields are marked by this one. And then you put a MIME type. This is very well known in web development. It just tells you what the data that you're looking at is actually. In this case, it's just a piece of text with hello world. And this is kind of the basics of an inscription. In more detail, the way this works, so we put it into a script. In Bitcoin, you have a UTXO set, and basically how that works is that you have a value that is locked by a script. So every time you make a transaction, you actually lock Bitcoin into a script or a smart contract or whatever. And so the first part is kind of the commit transaction, where you commit kind of the script, and then you reveal the script. This is the thing that you reveal, is this thing back here. This is then the actual data, and that's how you put the data on chain through this kind of commit and reveal phase process. And this is basically what you get. These are just some random early inscriptions. Somebody inscribed Doom. So here you see kind of, you can actually play Doom on chain. All the data is there. It's fun. And then there's a crypto dickbot, of course, a classic one. This was the first inscription. This is the kind of the Genesis inscription. And then you see here Bitcoin Magazine inscribed their magazine cover. This is a very interesting inscription because it's a thing we call a 4-megger, which stands for 4 megabytes. And this inscription took up a whole block. So the whole block was just this data, 4 megabytes. And it cost them a lot to inscribe. So yeah, let's see how this looks. So this is kind of just some details. So this is an inscription, has an inscription number 0. It has an ID. It also has an address associated with it, an output value. This is basically the output, the UTXO. And then the interesting part is the SAT down here. So as I said, this is a 2 kind of part system. The first part is Ordinals, which is tracking satoshis. And the second part is inscriptions. Here's just some more information. It looks very, you can see how big it is. This is, it's 792 bytes. You can see how much they paid to inscribe it. So they only paid 322 sats to inscribe. This was the first inscription, so it was very cheap to inscribe. You see when it was created. But yeah, let's look at the how this actually works with the SAT. So if we go on the SAT, we can see this is the SAT number. So SATs are very numerous. There's 100 million in one Bitcoin, and there's at the moment 19 or 18 million Bitcoins. So yeah, it's a big, long number. And we also came up with a way to kind of make this number more tangible. There's different kind of ways of representing this number. I don't want to go too into detail, but basically the percentile is kind of when it was mined, kind of it was in the first 60th percentile of satoshis. Then there's also a way to give a satoshi a name. These things are Bitcoin internal things. So there's difficulty adjustments and all these different cycles. And so you can kind of assign them different kind of notations depending on when the SAT was mined. You can see the SAT was mined in block 290,000. And then you can see, okay, this SAT has this inscription. And that's basically the basics of how it works. This is also an interesting one. This is the kind of the cover from Bitcoin Magazine, and they inscribed this whole thing. Here again, you can see has an ID, and then you can see here the Genesis fee. This is half a Bitcoin. So they, at the time, that was 15,000 euros. So they paid 15,000 euros to inscribe this picture, but it's forever on the Bitcoin blockchain and it can never be removed. So everyone who runs a Bitcoin node has this picture on there. It's kind of a flex to do it. It's called a 4-megger. It's a 4 megabytes kind of transaction. It's difficult to get this mined, so this is a non-standard transaction because it's very large. So what you have to do is that you have to give this transaction to an actual miner who will then include it manually in the block. And then, here you see also the SAT. It's a huge rabbit hole. There's so many details. There's also a thing called the rarity of a SAT, which kind of basically defines how rare a SAT is, and that is defined through when or where that satoshi is in the block. So the first satoshi of a block is a rare sat. So there's only, I don't know, 800,000 rare sat, uncommon sats. And then there's also these other cycles in Bitcoin that kind of define the rarity. There's the difficulty adjustment, there's the halvenings, and the first block of the first sat of these special blocks have different rarities. So you can also just collect sats without inscriptions. They have these cool kind of, these cool rarities. And this is basically how it looked. So this is from mempool.space, and you can see kind of all these small little boxes are transactions, and then you see this huge box. And this huge box was just this huge transaction with this picture, and it just basically took up the whole block. This is just a short timeline. I can a bit explain my background. So I was, I don't know, a year ago, or more than a year, I was hanging out in obscure areas of the internet, and I came across this guy who was working on this ordinal theory stuff. He had just come up with the base ordinal theory part and was coding something on Bitcoin on GitHub. And I was this looks interesting. And then I just started contributing. And then out of that, we kind of came this working relationship. And then we created this whole kind of, we coded together in Rust and created this kind of binary to this actual program that could actually run and discover the ordinals, or not discover, but that parse the ordinals, and actually a tool to inscribe and everything. And then we launched it in February, and then since then it's just been up and to the right. Here's some highlights. I don't know. This was in December, so this was kind of our test transaction. Then someone else we were working with kind of just as a joke inscribed a crypto dick butt. And then we launched it here in February, on the 20th something. Ord client, we launched it officially for mainnet, and then it just the activity took off. And then someone inscribed these rocks. I don't know if somebody knows the ether rocks. And somebody just took the ether rocks and put them on chain. That was kind of the first big collection. They're worth hundreds of thousands now. It was a pretty crazy timeline. So here's also another interesting kind of thing that you could see. This is this is the mempool. This is a visualization of the mempool. So the mempool, same as in Ethereum, is just where transactions kind of wait and sit to be mined. And you can see there was not a lot going on Bitcoin. It's kind of nothing really going on. Yeah, you have these small spikes here. But what this is, this chart is basically, it's a nice proxy for activity on Bitcoin. And as you can see, as soon as we launched it, here, this is Casey. This is this is the creator of it. He had the original idea, and then we kind of came up and coded it together. And here he announces it. Inscriptions are finally ready for Bitcoin mainnet. Inscriptions are like NFTs, but are true digital artifacts, decentralized, immutable, always on chain, and native to Bitcoin. And then we launched it, and then since then, the mempool has not really been cleared at all. So, this is kind of another chart. Wait.
The green peak was BRC20.
Wait, my clicker's a bit. So yeah, I mean, these bands are basically this. The green peak doesn't tell you anything about BRC20 or anything. These bands are just how much fee they paid. So I think the red band is the 1 sat per VByte. This is 2 to 5 sat. It's just a visualization of how much people are paying per byte, and then how full the mempool is. So I will later show you some other stuff on BRC20s. And then, and here's another kind of way to visualize the impact of ordinals on Bitcoin. So this is when we launched it, and now it's basically 50% or 60% of all transactions on Bitcoin are ordinals transactions. This is the same thing, another visualization for the same thing. You see here it's launched, and now it's over 50% of the transaction volume is inscriptions. But why is this good? Why is this good for Bitcoin? So Bitcoin kind of long term, there's this discussion about Bitcoin security budget, and at the moment, Bitcoin miners are paid mostly through the block subsidy, which is like which halves every 4 years, called the halvening, and it's decreasing exponentially. So in the long term, Bitcoin kind of has to rely on the fee market since the subsidy goes away. So you have to have a healthy fee market that will kind of pay the miners to secure the network. And with Ordinals bringing kind of activity back to Bitcoin, it furthers kind of this very important aspect that you have a always kind of full mempool, always kind of available fees and high fees as well. And this is just a statistic to kind of show all of this. Like since since we launched it, we've paid over 56, or not we, but like everyone who has inscribed has paid like $56 million in fees to miners just to inscribe. And then here you see the same thing. It's kind of how much per day miners are getting, and it's like at the moment it's 200,000 per day just through the inscriptions. But there's also downsides. So the state in Bitcoin is the UTXO set, whereas in Ethereum you have these accounts and the balances. In Bitcoin you have the UTXO set, and the UTXO set is the actual state. So it's the value of an output and the script that locks it. And this has been like around 6 gigabytes, but since we kind of made inscriptions, it's gotten a lot bigger. It's gone up to 8 gigs or something. And as you can see, it's going up very fast. This doesn't necessarily have to do like directly with inscriptions how we envisioned it, but there has now been protocols, meta protocols on top of Ordinals, on top of inscriptions. One of these meta protocols is called BRC20, which is basically just it's basically ERC20 from Ethereum ported over to Bitcoin, and gives Bitcoin also a sort of kind of account model. So I don't want to get too into detail of this, but these sort of transactions, the way this protocol is designed, it's very inefficient, is that it creates a lot of outputs, and that's why it has been rising. So there's some downsides. I'm talking to the BRC20 people to kind of rethink their protocol, make it fit more easily into the UTXO model of Bitcoin. But yeah, that's kind of a not nice side effect at the moment. But again, here's a positive side effect. So you see here is the Bitcoin Taproot utilization. Taproot is this new upgrade to Bitcoin that was introduced 2 years ago, and it wasn't really used at all. It has really cool features, but we were kind of the first real use case for Taproot. So I was talking about the envelopes before, and we put it into the Taproot script path spend. And so we are kind of now using this actually kind of new feature of Bitcoin. We're using it in a very primitive way, but we're using it. So you can see now like the Taproot utilization is going up. This is also very good for the anonymity on Bitcoin. Taproot it gives you like more privacy, more anonymity, and you want, of course, the anonymity set to be big. Like if you're the only one transacting and doing Taproot transactions, it's very obvious what you're doing. But if there's a lot of other Taproot transactions, it's easier to actually use the privacy features of Taproot. So yeah, this has been a nice kind of side effect of it. Then just quickly, some marketplaces, some volume data. I just pulled this from Dune. There's a couple marketplaces. Probably none of them, maybe OKX. All the volume on these is the total over the last 6 months has been like 300 million. That's pretty small still, but like we launched it 6 months ago, so it's really like in the early stages. Whoops. Oh, exactly. So yeah, I'm a developer, so I always want to kind of find new devs. So if you're interested in this, go check out the GitHub. We write everything in Rust, top to bottom. It's a very fun project. We have very high standards. We do a lot of testing. So yeah, if you want to contribute, just open a PR or an issue or whatever. Looking forward to that. And just to wrap it up, if somebody asks you like, what is Ordinals, what are inscriptions? It's basically this. It's an immutable, on-chain, Bitcoin native digital artifact. And yeah, if you want to learn more, like we have really nice docs. Like just go to the docs.ordinals.com. Like Casey is a very good writer. He wrote a very nice like documentation about how it works and also kind of embeds it culturally. It's very nice. If you're more like into Twitter, this is my Twitter. I mean, I found out about Ordinals over Twitter. So if you're more like a social media person, go here. And if you're more like a dev, go check out the GitHub. Yeah, thanks for listening.